Hello, everyone. Welcome to the BigCode Project 2022 review. I'm Sean Hughes from ServiceNow, and I'm one of the hosts today. I'm going to be handing over to Leandro van Vera from Hugging Face and Harm de Vries from ServiceNow, who will take us through the start of the show. Over to you, Leandro.
Thanks, Sean. Just a brief overview of what we want to look at today. Here's the agenda. We set out with a timeline and we want to have a quick look at it and see how it evolved. There has been a lot going on in the BigCode community. A lot of people have joined. And then the main focus of the webinar is actually having presentations from all the contributors and working groups to see what everybody has been working on the past few weeks. Finally, we then want to quickly talk about what some of the next steps are, looking forward to the next year, and answer a frequently asked questions, which is, how can I contribute to BigCode? So let's look at the timeline. When we did the first webinar, I think that was a few weeks after we launched. We showed everyone that timeline, and the main goal was to release a data set mid-October. So that was the release of the stack. Since then, we actually did another release too, and we set out with the broad goal of training a large model between now, essentially, and end of phase one, which ends in March. So that was the original timeline. Since then, a lot has happened. So maybe you can go to the next slide. Yeah, so a lot has happened since we launched. As of this week, we have now almost 500 contributors or collaborators in BigCode. We had some nice coverage in the press. So people are noticing the things we're doing. There's been some coverage of the initial launch of BigCode. We've been covered in the prestigious Import AI blog from Chuck Clark with the release of the stack, and also in VentureBeat and The Verge. We had some nice coverage about the data sets we released and kind of the goals and the mission of BigCode, which seems to resonate quite well with the press and the community in general. The main milestone we had so far is the release of the stack a few weeks ago. Since we released it, it has become the third most liked data set on the hub, which is no small feat. We beat Wikipedia, we beat Glue. So we're currently third in the list. Only two diffusion data sets are more popular than the stack, which is, I think, a really nice result given that diffusion models are so popular at the moment. There has been some community outreach as well. A few weeks ago, we organized a social at Near-deduplication, where I think roughly 100 people attended. We made some t-shirts and stickers that we handed out. And also Jian organized a nice gathering at EMNLP. And that really shows that everyone can start a social or organize something for BigCode. It doesn't need to be organized by Harm or me. It's really a community project, and we really enjoy the activity that has been happening. Cool. Yeah, we go to...
What's going on? Oh,
I think you clicked on the link.
Is that back? No.
Yeah.
Oh, no.
You clicked on the link again. Another link.
Nice. Yeah, it's not working. Now it's yes. Okay, we're back. We're back. And I guess I'm taking it from here, right? So, yeah, so we have a couple of updates. I mean, since we started, right, we had the, just the big goal of training a 50 million parameter model. But just by listening to the community and seeing what people are up to, we decided to do like a first iteration or cycle before Christmas. And so just to get sort of like the engine, to warm up the BigCode engine and get everyone going into like execution mode. So we basically, that's what we're going to present today. So like what our updates are from the whole community, right? So we've been, a lot of people have helped us sort of like getting through this first release, and we just want to feature all the great work that's been done by the contributors. And before I'm going to hand it over to the contributors to present their work, I just want to sort of like give a brief overview of like the high level plan of this iteration. So what we want to do is like first like de-risk some of the architectural choices that we had for training a large language model, more or less an autoregressive model. So we specifically looked at like multi-query attention and like fill in the middle, which is like two approaches where we were running ablations for, and we're going to present results for. And the other thing, what we looked at is like, what is the best way to pre-filter filter our like source code data set or the stack. So we've learned from the first iteration, right, like from the data set we released, that near-deduplication was very important to get strong performance. So we want to continue that line and see if there are more gains on the table. And so we're going to present that to like final results later, but I just want to like now give the mic to Sean, who's going to tell a little bit about the work that's been going on in the governance working group.
Thank you, Harm. So as you can imagine, opt-out is one of the more sensitive topics from a governance perspective. Interpretations around fair use, consent, and ethics are all big factors that come into play. So we had a couple of task forces focused on these issues. And the task force for dataset license put in considerable effort to evaluate our open source licenses to determine which would be suitable for BigCode. I'd like to offer a special thanks to Liz Via with help on identifying which licenses are permissive. That was no small undertaking. So as a result of this, we were able to narrow down 193 permissive licenses with copyleft removed. As Leandro had mentioned earlier, we had got the significant attention of the machine learning and open source communities with the announcements of BigCode, the stack, and Am I in the Stack? The tech media noticed, and they published articles that called out our plans to enable opt-out. Am I in the Stack is the first of our open source tools to provide agency to developers to opt out from model training. And so far we received 25 requests via the opt-out form. Ahead of releasing Stack 1.1, there were 9 people that made the cutout date for opt-out. They had about 299 repositories from our GitHub download, of which 138 have got permissive licenses. So those 138 repos have been excluded from the Stack 1.1, so which did not have permissive licenses. We'll remove the remaining opt-out requests that came in after we released 1.1, ahead of starting model training in the new year. So I think we made an announcement the other day on Twitter that we're inviting people to check out Am I in the Stack, and if they have concerns, to submit their opt-out requests before the December 31st cutoff. Lastly, we do plan to keep working on this problem in the new year to improve consent opt-in / opt-out process. And we welcome more contributors to help shape this work. So do get in touch if you'd like to participate in transforming how we do this. All right, thank you. And I think up next will be Carlos.
Hi, everyone. I'm going to speak about the model license. So the license we are currently developing and thinking for the BigCode set of models. As you may know, because we have it under our webpage. The source code is available, will be available under an Apache 2.0 license, but when it comes for the machine learning model, the model is going to be released under an open and responsible AI license. So basically a license allowing open royalty-free access also to the model parameters, weights, and at the same time enabling the user to use it or even to distribute or redistribute derivatives of the model, either for non-commercial purposes, research purposes, or even commercial purposes, always complying with a set of specific use restrictions in which we do not want the user to use the model for instance, malware generation or dissemination of malware. Now, next week, we are going also to release a specific FAQ for the users or also for you as a community to better understand this type of license. And even if you have any subsequent feedback, we are open for feedback. It would be even very, very great. We would be super grateful for this. Yeah, and that's it from my side. Thank you.
Dennis.
Hello. Yeah, so since the stack version 1 have been released, we got some input from the community and we decided to release an update. So update mostly includes like the more programming languages that Leandro have collected, and also the updated like permissive license list with the help of data licensing task force, which include Luis, Carlos, Harm, and our people. So 193 licenses were identified as like permissive. Also, we removed some licenses we wrongly included in the like first run. So yeah, so in the end, we had our data set increased from 3 TB to 6.4. Yeah, and we also included additional meta information. Please, yeah. So yeah, we ran through events on the repositories and collected the number of stars, issues, and forks. Well, it's not actual number of issues, stars, and forks because it's just an event of such sort. So it's like approximation what you would found on the GitHub. So, but it's a good approximation. So we just included it. And also, as it was from event on the GitHub archive, so it was from 2015 until 2022, something like that. Yeah, please. So yeah, so how the new stack version like include this information? Yeah, as each unique file can be in more than one repository, and actually it's often is because like about 90% of information in GitHub is like repetition. So what do we have? So the stack contains just the unique content, like unique file. But what we will additionally be including is we will be including like repository information for each repository we include. So it's about like 19 million repositories of permissive licenses what we took files from. So yeah, and how we include information like stars. Yeah, so each repository contains like star count. Yeah, and when we have files in this repository, and when we have file in a stack, which can be in more than one repository. So what we do, we look for a repository with maximum amount of stars, for example, and when we take this information as a metadata to a stack with content of that file. And also we have additional things like hashes. So we basically can reconstruct the directory structure of that repository. Almost, because some files were just not included. Like if we're not of languages that were included, or we even didn't store them because they're binary, there were some errors and so on. Yeah. Please, next slide. Yeah. So what we will be doing shortly, we will release this meta information as an addition to the stack itself. So it will be like 3 tables, which will be like sharded or bucketed by repositories. So it's like manageable because it's actually quite a big database actually. So there will be a table for repository information itself. So as you see, it will contain like name, hash of head commit, status and stars count, force counts, issues count. Also, it will contain like information of a file. Each file regardless if it was stored or no. So we will know like the full content of a repository as we downloaded it, even if we do not store something. And also there will be a third table is of license, because we didn't know exact license of a repository, at least not for all of them. Because from some we were able to take this information from GitHub if owner of repository field it was fields, yeah. But for our repositories, we run a Go license detector, and it returns actually a probability that for each file in the repository which it detects licensing, it returns a set of probabilities for different licenses, yeah. So all this information will be also included. So like the researchers and community can look how exactly we decided that this repository is like permissive and so on. Yeah, so that's it, I think. And next, Lubna will be talking about personally identifiable information.
Thanks, Denis. So one thing worked on in this iteration is detecting and anonymizing personal information in the stack and the in-code datasets in general. While we can find some work for PII detection in natural text, there isn't something similar for code datasets that have similar contexts and different contexts and types of PII. So in this first iteration, we focused on detecting emails and secret keys and IP addresses. And before building the PII, we wanted to have something to like quantitatively evaluate the tools we're using. So we decided to annotate a benchmark. So thanks to all the BigCode contributors who helped, we were able to annotate 400 samples of code from the stack in different programming languages for PII. And then we built a pipeline for each entity. I'm gonna talk about it later, but it's mainly based on regexes. And then it was an iteration between the pipeline and the evaluation. So we used the evaluation to find where did our pipeline struggle and where did it shine, to try to kind of improve it. So after multiple iterations, we were able to come up with the pipeline that had kind of decent results for each PII type. And the last step is after detecting the PII, you have to anonymize it. So for emails, for example, we replaced them with some dummy emails and secret keys with other generated keys, and IP addresses with the private IP addresses. You can find the code in our GitHub repository. Next slide, please. So as I said, for this iteration, we used regexes because they're fast to execute and also to build. And we also added some filters on top. And for the keys detection, we used a tool called Detect Secrets. It has different regex and entropy-based plugins. And we added some filters on top to reduce the number of false positives and negatives. You can see here a screenshot from space that we built to kind of see where do we find the PII and what do we replace it with. And the figure on the right shows the scores that we got. So for the email, both precision and recall are very high. Same for IP addresses. But for keys, we had to make a trade-off between precision and recall. And so there's still some room to improve it. In the next steps, we will try to detect more PII, first by annotating a larger benchmark and also by trying to cover more entities. Next slide, please. So now that we talked about PII, something else we worked on in the working group of datasets is the data ablations to find which filterings can improve the performance of the models. The first filter we tested is the comment to code ratio. The motivation behind this filter is that one common good coding practice is to include comments in your code. So we can expect files that have a high number of comments inside them to be better than files that don't. So we filtered out files that have a low proportion of comments, but also files that have a very high proportion. And you can see here the cumulative distribution of this filter. So we used as a minimum 1% ratio, and that removed almost like 20% of the data. And as a maximum, we used 80%. You can find the code for the filter in the analysis for this filter and the other filters that we'll talk about in the GitHub repository. And now Chenghao will tell you about near-deduplication.
Thanks, Lubna. Before I start, I want to say thanks to Denis, who did all the heavy lifting to do all the first iterations of deduplication. Without him, we couldn't have the data set today. So as you may recall that in Stack 1.0, we actually have this very standard me hash and locality sensitive hashing index to help us to remove 37% of the files. And that brings up about 13% to 76% improvement in different benchmarks and different settings. So between 1.0 and 1.1 release, we did a lot of experiment on how to reduce the false positives and false negatives in documents we care about. And now we end up in a different hyperparameters for this deduplication algorithms, which we increase the engram size to 5, and also remove the false positive check, which actually decreased the deduplication time a lot. And also we increased the deduplicated documents from 37% to 47%. Now we don't have all the results for the deduplication evaluation yet, but we will see some early analysis in slide 35. Next animation, please.
Yeah.
Okay. So the next step for our deduplication work is basically to figure out, okay, why did it work in the first place and why it didn't, if compared to the final results, and what are we missing? So the question I always had is, when we do deduplication, are we actually hurting the model's performance on generating templates? When you investigate the duplicates we discovered so far, a lot of them are templates for some web framework like Nginx. So, but we are not evaluating them in our benchmarks right now. Another question is how we gonna scale this duplication work to the next terabyte of that we are going to communicate for the next version. And I'll hand it off to Dmitry. Thanks.
Okay. Thanks, Chenghao. I'll talk about fertility rate of tokenizers, how it helps to filter a dataset and also to analyze tokenizer performance. The fertility rate, excuse me, I hear me actually.
Yes.
Yeah, okay. Fertility rate is a measure of how many tokens are generated by trained tokenizer compared to native tokenizer for a specific language. The native tokenizer is the default tokenizer used by the programming language or tool for that language, and it's typically based on the rules of the language for splitting tokens, for splitting text into tokens. A lower fertility rate indicates that the trained tokenizer is more effective at encoding the text, meaning that it generates a shorter sequence of tokens that still accurately represents the original text. This is important because shorter sequences requires less memory and computation to process. The table and graphic below shows results for different pre-trained tokenizers. In general, the average fertility rate for our dataset around 2, and it reaches 10 and above for hard percentiles. If you compare tokenizers, it's clear that BigCode tokenizer performs well. Only encoder tokenizer produces shorter sequence in the general. Please, next slide. The fertility ratio can be used to filter out undesirable files from the dataset. By observing fertility ratios of those files in a dataset, it is possible to identify those that contain large amounts of text, hard-coded database entries, or other unwanted content. By setting a threshold for fertility ratio, it's possible to automatically exclude these files from the dataset. For example, the left snippet of code has fertility 2.1. It looks like a good example of code indeed. The right one has fertility over 100, and it represents one of junk files which occurs in the unfiltered dataset. It's all. The next Chris will talk about tokenizer training.
Thank you, Dmitry. Right, so for this first iteration of model training, we went for something rather conservative, risk-free, as it were, that we knew would work in order to have something trained and ready quickly for the Christmas model. So we opted for no normalization, seeing as code files are typically well behaved, so no Unicode normalization, nothing like that. The pre-tokenizer we chose is basically just the one from GPT-2, both the regex and the fact that it's byte level, with an added digit splitter on top. We didn't want the tokenizer learning random combinations of digits, so none of like one token for 192 and one for 168, because that's what IP addresses tend to include, but rather wanted to delegate this composition downstream to the model itself. The tokenizer itself uses the byte pair encoding algorithm, so byte level byte pair encoding. It was trained on 600,000 entries from the stack, 200K entries per language. A reminder that the models training are training on Java, JavaScript, and Python. So we had a few gigabytes of data to train the tokenizer with a vocab size of 49,152, chosen to be close to 50K, a number that works well in practice for code models, but also to be divisible by 64. And the reason for that is that the vocab size will determine the size of the embedding matrix, and hardware considerations, specifically FP16 matrix multiplications on NVIDIA cards, dictate that matrix dimensions be multiples of 64. The screenshot that you see, it demonstrates how the tokenizer actually behaves, so feel free to use that. Try to see if it breaks, let us know. And with that, all that's left for me to say is that the tokenization working group is still exploring different avenues for the bigger model, and we would love for you to join us if this is something you're interested in. And next up, Raymond will be talking about the move to multi-query attention.
Yes, thank you, Chris. So yes, one of the architectural changes we implemented for the Santa models is multi-query attention. And so thanks to Joel for helping on the implementation of multi-query attention in Megatron. And so as you may know, in most transformers, the layers use what's called multi-head attention, in which each of the heads computes its own sets of values, keys, and queries for each of the elements in the input sequence. And in multi-query attention instead, we'll want to share the values and keys. Yes, thank you, across the heads. And so the goal for that is to get improved speed at inference. And later, Alex will talk about that. Now the question is whether this simplification of the layers has an impact on the performance. And in our experiments, comparing multi-query attention with multi-head attention on code models, there is a very slight drop on human eval, but overall the results are still very comparable to multi-head attention. So that's probably something we want to keep for the later models. Next slide, please. And another change we made to the model for the Santa models is the addition of infilling. So some recent papers showed that you could train autoregressive language models to do infilling in addition to the regular left-to-right pre-training without losing any of the performance. And for code models, this would be especially interesting because you can imagine applications like docstring generation conditioned on the function definition and signature, or type inference, or many other things. Next, yeah. And so in our experiments, there's also like a very slight drop in performance when you compare to a model that's only trained to do left to right pre-training. But also here, the result is very comparable. And so it's also something we'll probably want to keep. Now I let Alex talk about some of the inference results.
Yeah, so I'll be presenting some of the results that we have, mostly Mayank and I have been doing on inference. So for downstream tasks, as you know, BigCode, these large language models for code, they have so many different applications, right? So it's pretty important.
Oh, wait, Alex, we have a hard time hearing you. Something happened to your mic.
Okay, is this better?
Yeah, there you're back.
Yeah, so Mayank couldn't make it today, so I'll be talking about the work that we've been doing on inference. And so the first thing is that for downstream tasks, since BigCode has so many different applications for example, completion, infilling, all of these things, we want inference to be really fast, right? So in the top graph, we show a benchmark that we have for GPT-2 with multi-query attention. And so on the left, we see latency versus batch size. And on the right, we see throughput versus batch size. And this is all with Hugging Face Accelerate. And on the bottom plot, what we do is we see the same thing, but for the Bloom model with the alibi embeddings. So that's kind of the big difference between Bloom and GPT-2 with multi-query attention. And we can see that comparing deep speed inference to Accelerate, we see that deep speed inference ends up being much better. But the issue that we have with just directly using deep speed inference is that it's not exactly trivial to implement it and adapt it for multi-query attention. Next slide. We also did some similar benchmarking in terms of the input length. So we took the input length and varied it from like 128 all the way up to about 2000. And we tried all these Hugging Face Accelerate models with multi-query attention, multi-head attention with FP32 int8 type quantizations. And we still saw that deep speed was better than all of these things. So in terms of next steps, we want to check out some of the other frameworks like PyTorch 2.0, which was just released, Apache TVM and AI template. We also want to look into more faster inference techniques. I think we looked into flash attention a little bit. We want to look into smooth quant as well. And we want to do some more experiments, for example, varying the output length and so on. And we're very open to having more contributors and having others help on this thrust. And now Arjun will be talking about the evaluation.
All right, so I'm going to stop talking about evaluation and then hand it over to others. So to begin, there are several ways you might want to evaluate a code generation model, like the BigCode models. But a fundamental question to ask is, can the model generate working code given a natural language description? So there are a number of benchmark suites that are of this kind, and I just want to walk you through one example. So in the top row here, you have an example Python benchmark that's adapted from the OpenAI Human Eval benchmark suite. So the prompt to the model has the signature of a function and a natural language description as a docstring. Given this input, the model completes the body of the function, and then there's a bunch of hidden tests on the right that are used to test that the generated code is correct, that the model doesn't get to see. And I've only shown 2 tests here. The actual benchmark problem has several more. So there's a whole bunch of benchmarks of this kind for Python. There's a few for C++. But the question is, how do we evaluate the performance of other languages without going through the painstaking effort to build new benchmarks? So the approach that we're taking is to essentially translate the benchmarks from Python into other languages. So it's a 2-step process. So step 1 is to infer types, which is necessary when we're benchmarking a typed language like Java. Up here, it's pretty straightforward. For this example, it's sort of fairly obvious that the inputs are lists of floats and the output is an int. It gets more complicated when you have things like nuns or like heterogeneous types. And the second step is to actually translate. So here we have a sort of canonical rule-based compiler that translates the signature from Python to, in this example, Java, translates the types from Python types to Java. And we also translate like the terminology, like turning, say, lists into array lists, which is the Java terminology for this. And of course, we translate the hidden doc tests as well. We support 18 programming languages already in the suite that we have. The current Santa models just support JavaScript, Python, and Java. So those are the results that we're going to present today. But 18 sounds like a lot, but there's many other languages that people care about. So one easy way to get involved is to help us support more languages. This is joint work with Carolyn Anderson at Wellesley College and Yang Tenzi at Northeastern. And the link on the slide has a link to the code base that we use to do this. So on the next slide, Lubna will continue talking about evaluation.
Yeah, thanks, Arjun. So you may know that we have an evaluation harness where we're trying to build one framework to evaluate on code benchmarks. So what's new with the evaluation harness is that we did a Codebase refactoring, since it started as a framework just for 2 or 3 tasks, but then we added more and we want people also to add their own tasks. So we try to make the architecture similar to Eleuther AI's language model evaluation harness. So if you're familiar with that framework, it should be easy to add new tasks to this harness. And basically, you just need to make sure that the data sets you want to evaluate on and the metric are on data sets and evaluate. And then you create one file like the list here, for example, human eval.py. You just copy a task and you have to fill the methods. There are descriptions and everything is clear. And you can make a PR, we'll be very happy to review it. And yeah, what's particular than this for this evaluation harness compared to Eleuther's is that it's more specific to code. So you can do parallel generation across a lot of GPUs with Accelerate. You can also separate the generation from the evaluation and more features. Now I think Harm's next.
Yeah, that's right. So yeah, so we just want to go quickly over the results that we got in this first cycles and the learnings so far. So I just want to say thanks a lot to Arjun and also Raymond for running also all the evaluations and also Raymond for the training runs as well. And I'm just gonna I'm just presenting, but they really did the hard work here. So for the first part, we looked into updating the architecture. So I think Raymond already did a great job at explaining multi-query attention and fill in the middle. So we looked at comparing, our baseline was a multi-query attention plus fill in the middle, so the architecture that we would like to go for in the future. And then we looked at, okay, if we remove, do multi-query attention without FIM, or do multi-head attention and include FIM, right? So see what happens when we remove one of the components. And yeah, so let's look at that. Raymond already quickly went over it, but just want to reiterate for multi-query attention, we did see a small drop in performance on human eval. This is the one, actually the Python version, the pass at 100 for human eval. And you do see, especially during the end of training, that you do pay a small price for using multi-query attention. But I mean, there's a few things, right, to take into account here. One is that actually the number of parameters is lower, right? So we're talking about a 1.1 billion parameter model for multi-query attention versus a 1.3 billion for multi-head attention. And at the same time, there are great benefits at inference time for multi-query attention running much larger batches. I think Arjun already experienced that in practice when he was running out of memory with multi-head attention, while you could crank up the batch size for multi-query attention. So I think we are pretty happy with what we can get from multi-query attention, and I think it's definitely an underexplored architecture in the PyTorch NVIDIA space, right? It seems to be well adopted in the Google environment, but not so much in PyTorch NVIDIA space. Then the other part, the FIM versus no FIM, of course there is a lot of people think we need some code infilling is an important task for these code assisting models. And so that's why we want to see, there was a recent paper, as Raymond mentioned, that was saying you can get it for free. So you can train these models with auto-completing, with infilling pretty much. And that would you would pay no price for just the standard left to right autoregressive modeling. We did not see, well, we can see from results, right? It's not the case that it's for free. It's we do get pretty close. We do pay a small price, So I guess it's like, we call like FIM for cheap, I guess. And so we're probably gonna stick to that as well moving forward. Yeah. So that was the architecture ablation. Then the other thing we investigated in this cycle was the filtering. So you've seen all the different components, like coming by all the different filters that we implemented and explored. Just to recap, right? We have one filter that we're filtering for stars. So like we only take 5+ stars. We looked at comment to code ratio, as Lubna explained. So we look, yeah, like the thresholds are 1% minimum, 80% maximum. We, like as Dmitry explained, we looked at tokenizer fertility. So remove the tail when the tokenizer has, well, when the fertility is really high. And then the last part, the more near-deduplication, that's what Chenghao explained, right? Like there are better, he looked at better high parameters for the near-deduplication, came with the, so like more like 5 grams and sort of like a lower threshold for removing the false positives. And yeah, so let's look at those results. Oh, well, actually should first, I forgot about that one. But yeah, we, just to mention like how much data is removed with each filter, it's probably pretty informative. So for Python, we started with 75 gigabytes like of the data. So this is the standard. This is already near deduplicated actually. And if you then filter for stars, you remove a lot. So like that's the most aggressive filter we've had. And that's basically become like there's a lot of repository without stars. So if you're only going to select for stars, you remove the majority of the files. The other filters are less aggressive. It's sort of in the same range, right? Like the comment to code ratio removes like 10 gigabytes here. More near-deduplication, slightly more towards 15, and tokenized fertility is actually not removing that much. Cool. So let's look at the results. I think like so like I extracted here on the left, you see the human eval pass at 100 for the 3 languages, like evaluated on the multi-PLE benchmark that Arjen presented. And I think the first main takeaway is like, don't filter for stars, like that you really pay the price. And that was like somewhat surprising, right? Because there are a lot of people in the literature, like I think maybe I'm saying something wrong, but maybe I think it was part of the PAL, and like also like Daniel Fried's like work was suggesting to filter for stars. So yeah, but like here we see that's not a great idea. Then the other ones, like I think the one we should, like the strongest performing, like you see a real boost again with more the alternative version of deduplication, right? So this is the somewhat greenish bar here, and it's like for all languages you see a clear boost in human eval performance. So that's like one thing that's probably worth keeping. The other filter that's like seems to do something is the comment to code ratio, like the one in orange red. And there it's a little bit more variance, right? So like for JavaScript and Java, it doesn't seem to be that great. For Python, we do see improvements over the sort of like the other baselines, though it's like not super strong effects, but it seems to be doing something. And then if we talk about the other ones, like fertility, it's like small boosts. So for now, like for the other run that is that we launched actually just yesterday, and that we're gonna, like, that's basically a model we're gonna train for longer and release. So that's training with the new deduplication and with the code to comment ratio. And with that, I'm going to hand over to Leandro for next steps.
Thanks. So before I talk about like the the future plans for next year, maybe just a few words on what we're gonna do, like essentially next week before Christmas. So as Harm mentioned, we're currently training a model with more near-deduplication and the comments to code ratio for a little bit longer. For these ablation studies, we ran the models just for a short amount of time. But now with like that found setting, we want to run a little bit longer. And we plan to do a small release next week where we release those models and probably a small report summarizing these results a little bit so others in the community can profit from these insights. Then I think then everybody goes on a well-deserved holiday break. I think there have been like a few sprints in the past few weeks to get the data sets out and the models out, and also the governance group has been working a lot on like licensing and opt out and so on. So I think everybody deserves a little breather. But then in January and February, most probably like at the end of January, we will get access to more compute, and we want to use that compute to train larger models. So the common theme is going to be like scaling up. I think we now had a good start running first experiments, and now we want to use those insights and ramp up. And the goal is to train models that are probably, for starters, between 10 and 20 billion parameters. We want to use multi-creator attention and fill in the middle. Maybe also add some other things to it. We've been discussing in the training working groups if there are like special objectives that we should use. Should we use FIM or should we use UL2? I think there are like a few exciting things that we could consider. And then in addition to just scaling up, we also want to add more data sets. So far we've exclusively trained on code, but there are like a lot of interesting data sets that could be useful, essentially, especially because they contain like more natural text and kind of like instruction-like text. So we're looking at GitHub issues, GitHub commits, where you get like the difference of a commit plus a message. We are talking with folks from Stack Overflow to add a Stack Overflow data set. So that would be quite cool, where people ask questions and there are like rated answers that we could use to kind of get like a prompting into the model. And then also like more natural text. There's also a lot of ideas and work going on in the governance domain. As Lubna said, we had like some first progress in PII removal from code. We're currently thinking about creating an annotated data set that we could release and in some way, and that people could use to build like better PII removal from code. That seems to be like a very underdeveloped area at the moment. And also the governance tools are pretty much in development. So like most of the things that we build in the code, I think we think of these artifacts less as something we release once and then they're out there, but more as like living things. So we do it like that with the stack, where we try to update it, try to integrate more data, make sure the governance structure makes sense and so on. And we want to update these things. And the same is true for opting out. Also, as Carlos pointed out, like the model license group is actively working on making like a good license for code models. So that's kind of the plan for January, February, and then we hope to train some of these models, and probably like in March, the first phase is going to end, and we hope to do like a bigger release and hopefully have some exciting results and demos. Cool. So I want to wrap up by answering a question that we get quite often, and that's like, I find BigCode really cool, but I'm a bit lost. How can I contribute to BigCode? It's becoming more and more intimidating, I guess, to just join the Slack channel and write messages with like 500 plus people being there. And so I wanted to add like a few points on how you can start contributing. And first of all, you are free to join any channels that interest you. You shouldn't be afraid of writing messages or asking questions. I think the more active these channels are, it's going to have like a positive chain reaction where if people see these channels are okay to ask questions, then more people will ask questions. Another thing is like these working group meetings. I think most of the working groups kind of have like a core group by now, where it's always a little bit like the same people joining and discussing. But you shouldn't be intimidated. Like anybody can join any working group meeting. If you don't have anything to contribute, you can also just listen in or ask questions in the chat and so on. So the first point really is about don't be intimidated and join wherever you want. Secondly, if you have time and you want to help, or if you have ideas, just speak up. So if you want to help with data sets, just go to the datasets channel and say like, I have 3 cycles, where can I help? And I'm sure like some of the active people can then point you to some tasks. We also try to keep like the GitHub issues up to date. I think that works at times better than in others, but if you have time, it would be a shame if you don't contribute because you don't see like an issue that you can readily tackle. I think there are tons of like interesting analysis that you could do that are kind of like self-contained or small tasks and fixes where you can help other people. And usually I find it's like a first step issue. Once you start contributing somewhere, then you kind of like get into the flow, and then it's easier to continue contributing. So it's just about like doing some first steps. Currently, we're kind of like not dictating, but we have like an agenda of like the things we want to do. Like we want to train probably an autoregressive model in the 10 billion scale, but that doesn't mean that's the only thing that the BigCode project can do. So in the past, like I think a lot of people have mentioned interest in static code analysis, and so we opened a channel on that, and that's pretty much how you can go about it. So if you have an idea, you want to do something, you can open a new Slack channel and find a few people who find your idea interesting, and maybe you want to collaborate on it. I mean, that is pretty easy. Some projects might require some compute. As we mentioned, we have some compute at Hugging Face, we have some compute at ServiceNow. And if you're limited by compute, you can just message me or Harm or write it in a channel. And then we can surely find at least some GPUs where you can run something. I see. I'm going to answer that question later. So maybe can you go back quickly?
You want to go back? I just want to also like make sure that like we don't forget we have a couple of minutes left. So if people want to do Q&A, like maybe already write it in the chat, and then maybe Leandro, you can talk about the last bullet point here now. Yeah, I'm going to make it very quickly. I think the video is going to be online after, so you can go back and look at that slide. Here are just a few concrete things where we're currently needing help. So we want to create more data sets. Alex showed us like some inference result. There are like tons of testing that we want to do there. If you're more into governance, you can talk to Sean or Carlos. There's a lot of work going on there. And lastly, we want to build some cool demos. So if you have any experience with, I don't know, VS Code plugins or building demos for code, that's like a good place to go and play. That's the very short version of it. So I think we can all go over to Q&A. Cool. So I think there is like one, there was like one question in the chat that was unanswered. So like about like, what if people decide to opt out after the model is pre-trained on their code? I think that's an excellent question. And it's also like something that came up in discussions in the governance working group. So one thing we thought of, like we are implementing this tool, right? Like a sort of search index that when the model generates code, it will search through the training set to see if there's sort of when there are sort of verbatim copies of the training set, it can warn the user that, oh, hey, this is a copy, either point to that repository and to sort of for people to check if they comply with the license. Or the other option is, basically we can use that feature to also provide that information for opt-out requests, right? So either point, say like, oh, hey, this user has opted out, so maybe don't use it, or, and the tool, of course, will expose sort of like that the user has opted out. Or the other option is to just say, just to block that generation from the model. Say like, just always have like a filter, basically have a model that basically a service that filters like the generations. So you can sort of like, even when people immediately opt out, you can immediately update the index and sort of like make sure you respect that, decision. Hope that makes sense. Do we have other? I'm just checking. I can maybe stop sharing so I can see the chat. I think we're.
I did unmute Tanmay in case there's any follow-up question.
Oh, yeah. I guess if there's no follow-up, like Tanmay, are you? Is this a good answer, or do you have a follow-up question?
Seems like we're good.
Oh, I think he's good. Okay. Other questions? But no, I guess we're top of the hour, so it's perfect timing. So yeah, I guess thanks everyone for coming, listening to all the progress and the community has made. And yeah, I'll hope to see you all in the Slack. And I mean, stay tuned for the models next week. And then, and if not, please contribute to the new cycle in starting in January. Thanks.
And I also want to thank at this point everyone who already contributed. It has been a massive help. I think we wouldn't have achieved what we got so far without the lot of help we got. So thanks everyone who's contributing and helping or advising. It's really helpful.
Great. With that, I think we're done. Enjoy the rest of your day.
Thank you so much to all. Ciao.
Bye-bye. Thank you.
Bye.
Bye.